Okay, so here is an enzyme problem in which you're actually going to get to use the y equals mx plus b formula to calculate the Km and the Vmax, okay? So, what I'm going to do here is just start by reading it and then we'll start working on it. Tyrosinase, okay, the tyrosinase enzyme catalyzes reactions that produce brown-colored products, such as melanin in the skin, or the browning observed in apples exposed to the air. Food scientists interested in preventing the browning process in plant-based foods have shown that dodecyl gallate, I don't even know what that is, but it's not that important for the problem here, is the inhibitor of tyrosinase. Okay, it's an inhibitor. We know it's some kind of an inhibitor. We don't know if it's a competitive, uncompetitive, non-competitive. We just know that it's an inhibitor. Sketch the Lineweaver-Burke plot, okay, for the enzymes in the presence and absence of inhibitor and report the value for the table below, okay? Alright, so the first thing they want us to do is calculate the Vmax for no inhibitor. And we have this equation here, y equals 1.52 x plus 1.51. So what I want to do is I want to just recall what these things are on the Lineweaver-Burke plot. So let's just draw the basic axis here. I just want to kind of just recall what these things are, okay? So we're not confused. So this is 1 over V, this is 1 over S, right? And if we recall right, the y-intercept is the Vmax, or 1 over Vmax. And the x-intercept, which is going to be somewhere over here, is negative 1 over Km, okay? So if I have this equation here for no inhibitor, so I'll write no inhibitor. So no inhibitor, right? And I have this equation, it says y equals 1.52x plus 1.51, right? Okay. Not a terribly difficult equation. So if I want the y-intercept, I want to know where this crosses the y-axis. Well, all I have to do is set x equal to 0. So if x is equal to 0, then that tells me that y is equal to 1.52 times 0 plus 1.51. So y is equal to 1.51, right? Now, you may be saying, okay, that's the answer. That's our y-intercept. Right, that is your y-intercept. But that's not your Vmax, and that's why this is kind of a tricky problem. Because remember, it's actually the 1 over the Vmax. So I have to do 1 divided by 1.51. So I actually have to do 1 in order to get the Vmax. In order to get the Vmax, I have to say it's equal to 1 divided by 1.51. Okay, 1 divided by 1.51. And if I do that, I get the Vmax is equal to 0.662. Okay, so up here under Vmax, I'm going to write 0.662. Okay, let's get that on there. 0.662. That's the Vmax for no inhibitor. Now, if I wanted to use the same equation, I wanted to get the x-intercept because the x-intercept corresponds to the Km. All I'd have to do is set y equal to 0. Okay. So if I set y equal to 0, right? I set y equal to 0. I'll do it out on paper here. I don't have a whole lot of space, so I'm going to try and make this work. So y is equal to 0 is equal to 1.52x plus 1.51, right? So I'm going to subtract 1.51 from both sides. And I'm going to be left with 1.52x. And I'm going to say x is equal to negative 1.51 divided by 1.52, and I get something like this, negative 0.993, okay? And it's a negative number, but that's what we want, because in order to get the Km, so the Km is now equal to 1 over negative 0.993, okay? So the Km is equal to 1 actually, I'm even making a silly mistake here. This should be negative, remember, because over here it's going to be negative, where this is going to cross the x-axis is in negative x. is in the negative x position, so it should be -1 divided by a -0.993, right? That's what we got. And we get roughly that answer is about 1.01. So the Km is 1.01, okay? So now we have the Vmax and the Km, so we found the two values for that. Now, they want us to also find those same values for the inhibitor, or when inhibitors added. Okay, well, I'm not going to do the whole algebraic calculation over here. I'm just going to say what the Vmax is, okay? Now remember, to get the Vmax, we have to do 1 divided by, now if we look at the equation here, it's 1.58x plus 4.27. So if we set x equal to 0, the y-intercept is 4.27. If I do 1 divided by 4.27, I end up with 0.234. So 0.234, okay? And, alright, you know what, maybe I'm just going to show this real quick. So y is equal to 1.58x, because I want everybody to be clear about this. This was something that I found, you know, somewhat difficult to think about initially when I was first in the class. So if that's equal to 0, so 1.580 is equal to 4.27, so y is equal to 4.27. Now if we recall, going back over here, I said the Vmax is actually what the answer we actually got was 1 over Vmax. If we want the Vmax, we need to divide the answer by 1, okay, or divide the answer into 1. So if we get this 4.27, simply do just like that. 1 divided by 4.27, you get 0.234. Okay? Now, same thing with x over here. We said we said y equal to 0. We subtract 4.27 from both sides, and what we end up with is negative 4.27. So negative 4.27 divided by 1.58, and that gives us this value. Okay? But the trouble is this is not the right answer, so we need to do 1 divided by negative 0.270. We get negative 0.370, okay? So that's going to be, again, making the same mistake here. It should be -1 divided by the value we had there. So if it's -1 divided by the value we had there, it's actually going to be 0.370. So, excuse me, even I'm confused. But I think we'll get through it. Okay, so I have those values, right? I have my Vmax, I have my Km for both of those things. Now I can plot those on the graph that I drew over here. Although this is getting a little messy, I can kind of plot those, and I know where they are. So if I want to plot the no inhibitor first, the Vmax is 0.662, but that's not the value I want to plot, right? The value I want to plot is the 1.51. So if we just sort of say, okay, here's 1, so here's 2, so 1.51 is right there. Okay, I plot that point right there. This is not to scale, so please, you know, don't quote me on this stuff. This is not to scale. It's just a rough graph. I don't have graph paper or anything. And our x value was negative 0.993, so that's very, very close to 1. So we'll say here's 1, right? Here's 1, or negative 1 rather. If I can keep my axis straight, that's negative 1 right there, okay? And so this is like right here. So this thing looks like this, okay? Roughly speaking. Okay? So this is no inhibitor. Okay? So that's no inhibitor. Now, the next graph here, for the next one, for the one with the inhibitor, we see that the y value is equal to 4.27. Okay? So 1, 2, 3, 4, here's roughly the value. Up there, okay, right? 4.27. And what was that Vmax? It was -1. So what was it? It was negative 4.27 divided by 1.58, and that was -1. So it was negative 0.270, okay? So this is going to wind up getting shifted over here. So there's negative 1, here's negative 2, here's roughly negative 2.70. So this graph is going to look something like that, okay? And this is with inhibitor. Okay, so that's with the inhibitor. And remember, this is negative 1 over Km, and this is 1 over Vmax. Okay, 1 over Vmax. So we can label the points on the graph. 1 over Vmax, negative 1 over Km, right? There we go. Everything is labeled on the graph, and we're pretty much all done with this. That's all we had to do. We had to fill in the table here, and we had to draw the graph. Now, the next part of the question, if I have enough time to finish it, I hope I do, says, what type of inhibitor is dodecel gallate? Justify your response and explain what this tells us about the mode of inhibitor binding. Okay, well, let's look at it. From this graph, we know one thing. It's not competitive inhibition. And why? Because they don't have the same Vmax. In order for this to be competitive, they have to have the same Vmax, right? So it has a smaller it actually has a smaller Vmax here, okay, with the inhibitor. So, which rules out competitive inhibition, and since no amount of substrate can fully overcome the effects of the inhibitor. So the Km is also smaller, okay? Notice we're going further in the negative direction, so that's going to mean this is going to be smaller, okay? Because a larger number over 1 is going to give us a smaller number, okay? A larger number, or 1 divided by a larger number is going to give us a smaller number, okay? So it's smaller, and the substrate appears to have a greater affinity for the enzyme. So this is consistent with an inhibitor that binds the enzyme substrate complex. And now think for a second, which one of these types of inhibition that I talked about binds the enzyme substrate complex and prevents the enzyme from releasing substrate and continuing the reaction to make product? Well, if you remember from the previous videos, it's on competitive inhibition. Okay, it's on competitive inhibition. That's the answer here. And I pretty much justified why by saying what I just said over there. I said that the Vmax is smaller, okay, and that's one of the characteristics of on competitive inhibition. This is binding to the enzyme substrate complex, okay. It's not binding to the active site, so it's not competitive inhibition. It's binding to some other site, changing the conformation, okay. It's binding to some other site. It's binding to the enzyme substrate complex and changing what's going on there, preventing it from continuing the reaction. There's another thing you might notice I never talked about, okay? You would notice that these actually